Even after reading that, I will stipulate, do not work on electronics if you think you know what you're doing. You have to be absolutely sure. Do not trust that anything in this video is correct. Vet it out for yourself. So here we'll be looking at the inside of the torch handle, and I want to be able to activate this with the Linux CNC machine. In order to do that, I am choosing to control the trigger remotely via relay. This will start by running a wire all the way from the plasma box to the torch end. This was not easy as I used my electrical 25-foot metal fish. I recommend buying a plastic one though. I took my time and I was careful, but I definitely recommend buying a plastic fish. I also fished a piece of trimmer line, so next time I need to fish a wire in, I can attach it to the trimmer line and pull it through. This wire I fished through will be attached to the blue wire. Right now the blue wire runs to one side of the switch and also runs to some contact pins that will touch the cap. This is so you can never activate the plasma arc while the cap is off. I want to keep that feature, so the wire I'm attaching will still only work if the cap is on, but it allows me to grab that side of the switch. The red wire runs from the switch to the machine, and I can tap that red wire inside the machine. So there was not a need today to run two wires. So now when these wires are connected to the relay and the computer sends the command to fire the torch will only fire if all the other safety mechanisms like the cap are in place, just as they would if you were closing the torch switch on the handle. Putting everything back in place in the torch handle was a little tedious, but I managed to work it all in, where it still fit nicely and functioned perfectly when I was finished. So here you can see both the wire and the plastic trimmer line that has been run from the torch to the box. I'm about to show you that I have the meter hooked up in the continuity mode, and I'm checking that the switch still works as expected in normal operation, and then I take the cap off and show that the closed switch performs as expected because the circuit is not complete with the missing cap. Now I'm going to test the circuit with the new wire I put in. This shows that with the closed switch, the wire has continuity as expected. Here I have already drilled the holes for the plastic 3D printed holder I want to mount inside the machine. I take the voltage divider board and I mount it to the 3D printed PTG, in this case, holder I made on my printer. This voltage divider board will have three settings: 50 to 1, 100 to 1, and an already divided pass-through at 50 to 1. I will be using the 50 to 1 divider setting. I will be hooking up wiring from both the positive and negative torch/ground hookups. I need this voltage divider as I want to use an Arduino circuit later on and code to read 0 to 5 volts and run my torch height control with it. The Arduino can't handle the 50 to 300 volts that might come from the torch as it's cutting. I picked this board up on eBay for around 50 bucks, so it was well worth it to me to buy it instead of design my own from scratch and send it off and get it repaired. Plus we got COVID, so I don't even know how the board houses are working right now. But I also put the link below for the guys that are interested in buying it from the actual website. And if you have that information, obviously you can search Amazon and eBay later. So having this case wide open on this side was really nice because, as you can tell, I had plenty of room to put that board in and eventual room to put on the connectors I want out the back. So this way it keeps it in a nice package inside the machine. So here we're looking at, with both the wires hooked up, negatives on top, positives on the bottom, and then what you're looking at through the board is how that voltage is divided. I'm just trying some close-up views so you guys get the idea of what I hooked up to and what the board looks like. So now I begin to show you how I'm going to put in the ports that'll go to the CNC machine. This is showing the connectors are all soldered together, and the top one has 24 volts coming in to power the board. It also has 0 to 5 volts from the voltage divider board leaving to go to the torch height control. The bottom of the connector has the wires to fire the torch from the relay from the Linux CNC machine. These wires will go to the housing of the Linux CNC machine and plug into the circuit boards there.